Hey class, this is be a review of Think Central Unit 1 practice test. Most important on this is make sure you go over the problems using step-by-step or view example, because this is a study guide. It's not really about getting the answers, but making sure that you can show your thinking on the answers. So make sure you're drawing models and doing all the work and asking for questions if you need it. So basically we're being asked on this one to compare the two fractions, 4/8 and 4/9. So you can right away see that these are unlike fractions. So we can convert these to equivalent fractions to compare them, and I'll do that. But also you can see that because the numerators are both 4, 4 out of 8 is going to be more than 4 out of 9. So if you just draw two bars and draw like this, well, it's not accurate, but 4 pieces out of 8 will be greater than 4 pieces out of 9, just barely. But let's so you can compare them using the size of the pieces. So I'm just going to go ahead and use a common denominator, multiply them by each other. So 8 times 9 times 9 times 9 is 36, times 8 times 8 is 32. So you can see that 4/8 is going to be a little bit bigger than 4/9. And the final way to do this to compare fractions is use the cross multiply method. So 9 times 4 is 36, and 8 times 4 is 32. So you can see that this number is going to be greater than this number. So cross multiplying also will give you a comparison that you can figure out which one is greater than, less than. So the answer would be 4/8 is greater than 4/9. Looking at the next problem, they are too close to really see that, so I wouldn't use a model. I would definitely just go ahead and do equivalent fractions. And again, the easiest way to do this is to just do a multiple of 12 and 7. So 12 times 7 is 84. So let's use 84 for our common denominator. Multiply this by 12 and this by 7. So what you do to the bottom, you do to the top. You end up with 36/84, and this one you end up with 49/84. So obviously 49/84 is greater than 36/84. Something else to consider on this is if you look at 7/12, 7/12 is greater than 1/2. So if you use a benchmark fraction of a half, and 3/7 is going to be less than a half. So if you're using a benchmark fraction, you could also compare them that way. I like to just do equivalent fractions because with the same denominator, it just shows me right off the bat. But if you want to do mental math, this also works. One is greater than a half and one is less than a half, so that would also work. And also, if you just wanted to do a shortcut method, 7 times 7 is 49, 12 times 3 is 36. So if you compare those products, you can see that this number will be greater than that number. That is the third way to do it. Next problem is exactly the same. I've used a common denominator to very quickly do the double rainbow strategy, and you can see that 9/12 is greater than 8/12, so this number would be less than this number. You may have other ways to do it, but just one is fine as long as you're showing your work and your thinking. If you have another way of explaining your thinking, that would be fine too. Again, anytime you're faced with a word problem, you always want to unpack it. There's a person, his name is Gershon, and he lives 3/10 miles away from a soccer field. How far does he walk if he walks from his house to the soccer field and back? So make sure that you're going to the soccer field and back, so it's a round trip. So it would be using this model here, number line model. He would walk 3 miles to the soccer field, and then he'd walk 3 miles back to the soccer field. So altogether it would be 6/10 of a mile, or 3/10 and 3/10 equals 6/10. You could do a part-whole model, so this would be walking to, this would be walking back, and then this would be the total 6/10. And that could, if they ask you to, you could simplify that down to 3/5 if you wanted to, but I don't think it's necessary in this problem. All right, they've already given us a model here to use. We can see that model right here. Alton shoveled snow on 4/6 of his driveway, so he's showing this as 4/6. 1, 2, 3, 4. 4 out of 6. so that's 4/6 before lunch, and then he shoveled 2/6 after lunch. So this would be the 2/6 after here. How much more of the driveway did Alton shovel before lunch and after lunch? So they're asking you to do a comparison bar model. So before lunch he had 4/6, and after lunch he had 2/6. So the difference would be 2/6, 2 parts out of 6. Or you could say 4/6 minus 2/6 equals 2/6, and then that again could be simplified down to 1/3 by dividing numerator and denominator by 2. So the answer would be 2/6, or 1/3 more driveway before lunch than after lunch. Marcus and his family spent 1/3 of their vacation visiting relatives. That would be right here, and 6/12 at the beach. So if you look at this model right here, you can tell that this is 1/3 of his vacation, and this would be 6 parts out of 12 parts. So this would be 4 out of 12, which is the same as a third. What fraction of the vacation did Marcus and his family spend either with the relatives or at the beach? So they're asking you to just add those, find the sum of those. So you have, what is the sum of 1/3 and 6/12? But they give you this in the model, so 1/3 is the same as 4/12. So 4/12 and 6/12 is 10/12. And that again can be simplified by dividing numerator and denominator. That can be simplified down to 5/6 if they ask you for a simplified fraction. But the answer would be 10/12 or 5/6. Looking at this problem, after you unpack it, it's pretty clear that it's a part-part whole model. In other words, we're taking the two parts, we're combining them to make a whole. So I've drawn the model here, part-part whole, with the white and the ivory here, and then the total would be that. So we need to combine these two mixed numbers to get our answer. Alright, next step would be to line them up vertically between the holes and the parts. Good news on this is that we do have common denominators, so they are like fractions, so we can just add those parts together. 2 and 2 makes 4, so that would be 4/3 there. 3 and 2 makes 5, so that's 5 holes. So it's 5 holes and 4/3. Next step would be to simplify this. 3 goes into 4. Let me show you how I do that. So you know, 4 divided by 3 is 1, and then there's one part left over. So 1 and 1/3 would be that. I regroup the one hole over here. Now that gives me 6, so it's 6 and 1/3 as an answer, yards of lace. They're asking us to find all equivalent fractions to 3/4. So basically anything, what I do is I check each and every one, because the double rainbow strategy will tell me that. So how can I move from 4 to 12? It's a times 3. And is 3 times 3 equal to 4? No, so this one doesn't work. Alright, doing C, E, and B. C is 3/4 is equal to 27/36. Well, 3 times 9 is 27, and 4 times 9 is 36. So we are multiplying the numerator and denominator by the same number, therefore it is equivalent, so C would be an equivalent fraction. Obviously E is not, because there's no way you can move from double rainbowing it 3 to 4 and 4 to 3. There's nothing you can multiply numerator and denominator by to get that number, so that's out. And B, 3/4 equals 31/32. No, because 8 times 4 is 32, and 8 times 3 is 24, so that doesn't work, so that's out. Final two left. Let's do the double rainbow here. 4 times 5 is 20, 3 times 5 is 15, so yes, this is an equivalent fraction. And 4 times 7 and 3 times 7 is 21/28, so that is also an equivalent fraction. Correct answers are C, D, and F. Same problem as the last one. I'll go ahead and set up the equivalency. So is 12, how can I move from a 12 to a 4? I'm going to divide by 3. 8 divided by 3 does not equal 2, so this is not an equivalent fraction. For B, 8/12 is equal to 1/3, well, I'm going to divide this by 4. 12 divided by 4 is 3. Divide that by 4. 8 divided by 4 is 2. So this is not an equivalent fraction. And for number C, 12 times 3 is 36. 8 times 3 is 24. So that is an equivalent fraction. Now we'll try the other three. All right, looking at this, on a problem for this one right here, there's nothing you can multiply by 8 to get to 5 or 12 to get to 15. What you do need to look at, though, is simplifying these fractions because they may be equivalent. So if we simplify these down, we divide these both by 5, we end up with 1/3. And then if we divide these down, divide by 4 and 4, we end up with 2/3. So they aren't equivalent, but it's best to compare simplified like fractions. So E would not be a correct answer. Dividing 8 by 4 gives you 2, and dividing 12 by 4 gives you 3. So this is an equivalent fraction. And multiplying by 3 and multiplying by 3, that gets you 36. This does not get you 18. That gets you 24. So that is not an equivalent fraction. Two correct answers are C and D. One thing you'll notice, though, is I'm not doing any mental math. I'm actually showing all my work and coming up with the correct answer because this is a test. So just circling C and D because you think is right, you can't do that. You have to show your work and do the actual procedure. This question is fairly easy. You just need to enter an equivalent fraction for the mixed, enter an equivalent mixed number for each fraction. So we are just going to be converting each of these into a mixed number. I'll do it multiple ways. First way I'll do it is I'll just draw 13 parts. 5, 10, 13, and I'll circle groups of 4. One group, 2 groups, 3 groups. So I have 3 holes, and then there's 1 part left over. That's 1/4. Okay, so that would be the first answer, 3 and 1/4. Next way I'll do it is I'll use division because this fraction bar is a division sign. So how many times will 3 go into 22? It doesn't go in any here. 3 times 7 is 21. Subtract those, you end with 1/3. So this would be equivalent to 7 and 1/3. 22/3 is the same as 7 and 1/3. For the third problem, I'm going to do 13 halves. So I'm going to 2 halves is a whole, 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 and 2 halves and a whole. So I end up with 1, 2, 3, 4, 5, 6 holes and 1 part left over, and that's 1/2. So 13 halves is the same as 6 holes and 1/2. And for the final one, I'll use division. 5 goes into 11 2 whole times. That takes away 10 parts. There's 1 part left over, and that part is 1 part out of 5 as a whole. So 2 and 1/5 would be the mixed number for that fraction. Problem number 11, basically, they are just asking you if the two fractions are equivalent. So I'm going to blow that up so I can see it better. Using the double rainbow strategy, 5 times 3 is 15, 6 times 3 is 18, so yes, they're equivalent. 8 times 3 is 24, 9 times 3 is 27, yes, they are equivalent. Well, this is a half, and this is more than a half, and there's no way you can multiply anything by 12 to get to 10, so those are not equivalent. But if you wanted to simplify both of those just to check, you do 12 22nds, you divide by 2 and 2, and you'd end up with 6 11ths, and then simplifying 10 20ths, you divide them both by 10 because 10 is a common factor of both of those, so you end up with 1/2, and you can see that those are not equivalent. 20 divided by 4 is 5, and 48 divided by 4 is 12, so they are equivalent. And 6 times 1 is 6, and 14 times 1 would be 14, so these are not equivalent. Again, super important that you practice your math facts, especially multiplication and division, because you have to have those readily available. If you don't know your facts, 1, study them, and 2, use a calculator to help you on these problems. You won't be able to use it on a test, but at least you're going through the proper procedure. Alright, this is a simple addition. Make sure you're checking the symbol of the problem. Simple addition. They're unlike fractions, so you need to find a common denominator for these. I'm going to do 15 because I know that 3, 6, 9, 12, and 15 are the multiples of 3, and 5, 10, and 15 are the multiples of 5. So I'm going to use 15. 3 times 5 is 15, 2 times 5 is 10, 5 times 3 is 15, 1 times 3 is 3, so I'm going to add up 3 fifteenths and 10 fifteenths, giving me a total, or a sum, of 13 fifteenths as my answer. Alright, this is kind of a wonky problem. You think Central does this. What you're going to do is you're going to unpack the problem, but then you are going to be only using these numbers to put in these boxes, one number in each box, or one symbol in each box. So Kate pours 2 cups of orange juice for herself. There's the 2 cups that she pours for herself, and another 8/9 for her sister. So this is a part whole model. You got 1 cup, 1 cup. That's 2 cups here and 8/9 here. How much juice does Kate pour? I'm sorry, 2/3 cups. So 2/3, 1/3, and 1/3 each one of these. So you need to add up 8/9 and 1/3. So we are going to do 2/3 here, 8/9 here. We're going to add, find a common. So I got 2, I got 3, I got 9, and I got 8, and I got the addition. So now I'm going to convert these to common denominator, 3 and 9. Let's use ninths because 3, 6, 9. So we're going to change these into ninths. That's a times 3 times 3. That's a times 1 times 1. That doesn't change. So it's 6/9 plus 8/9, and that's going to give you 14/9. And that's going to be the same as 1. 9 goes into 14 one whole time. And there's 5 left over, so it's 1 and 5/9 as the answer. We didn't use a couple of these numbers, that's fine. Alright, with any word problem, you're going to unpack it. Spencer's riding his bicycle 4 9/10 miles to the park. So when he starts, he has to go a total of 4 9/10. I'm drawing a picture model and to help me understand the problem. So he rides, the first part is he rides for 1 1/4 miles. 1 1/4 miles here, and then he stops to take a drink. So how much farther does he need to go? So that's a part whole model. We know one part, we don't know the other part, but we know the whole. So if we take the whole, 4 9/10, and then we subtract the part he's already ridden, that will give us how much further he needs to go. So I'm going to go ahead and rewrite this problem vertically because I'm going to need to separate the wholes and parts. Alright, first thing you see that they are not like fractions. Just to, let's go ahead and count the multiples of 4. 4, 8, 12, 16, and 20. 10 and 20. So the lowest common denominator I can use here are 20ths. Now I do my double rainbow, times 5 times 5. 1 times 5 is 5. Times 2 times 2. Make sure you're putting in the multiplication numerator and denominator. So I end up with 18/20 minus 5/20, and that is going to be 13/20. 4 minus 1 is 3. So it looks like Spencer needs to ride 3 13/20 miles more to get to the park. Okay, final problem. Ika mixes 8 6/7 pints of grape juice. So I'm going to go ahead and draw a picture of this. This would be my 8 6/7 pints of grape juice and 3 1/6 pints of cranberry juice to make punch. Okay, so she has 4 pints of punch left at the end of the party. So over here she has 4 pints left over. Estimate how much punch Nika served at the party by rounding the mixed numbers. So this is going to be a two-step problem. First thing I'm going to do is I'm going to estimate. So 3 1/6 would round down to 3 pints. 8 6/7 would round up to 9 pints. So this estimated amount of punch she made is 12. And now if she had 4 pints left over, actually I'm going to put that down here. If she had 4 pints left over, how much punch did they drink at the party? So 12, comparing 12 to 4 gives you a difference of 8. So she must have served 8 pints of punch at the party to have 4 pints left over. All right, that's the end of your practice test. Go ahead and study. Happy studying. Ask for help if you're unclear on any problem, and also perhaps request an additional practice test from us, and we will send another one to you on Think Central, and so you can practice more to get an A+ on your test, and then you can be very happy, and your parents will buy you a lot of presents.